Today I've thought about bringing for you about the parametric differentiation. After talking about different methods of differentiation, we have seen how to differentiate polynomials, we have seen how to differentiate exponential function, we have seen how to differentiate the logarithmic function. So now let's talk about how to differentiate the parametric differentiation or the parametric function. But before we talk about this, remember to subscribe. If you think that my content is useful to you, if you think that there's something that you are learning through my channel, I need your support. You subscribe, you share my videos, you add a comment, you add a suggestion, and even don't forget to like my videos. So, let's talk about the differentiation of a parametric equation. If we have a function like x, which is equal to 3 sine t, sine of t, and y, which is equal to 2t negative cosine of t. You see that we have those two expressions where we have one function which is x in function of t, and another one which is y in function of t. So the one which is called the parametric equation, this t is the one which is called a parametric or a parameter. This t is called parameter. We say that where t is called a parameter. T is called a parameter. So now when I'm going to differentiate, we find dy dx. Normally this dy dx, we say that this is equal to dy with respect to t. We find dy with respect to t, and we divide dx with respect to t. Dx with respect to t, like this. So we differentiate this with respect to t, and we differentiate this with respect to t. Then we get our dy dx. So according to this expression, what about this dy dt? According to this example, normally we say that this x is depending to t at a value of t. If we have, for example, if t is pi over 2, if t is pi over 2, x is equal to what? And y is equal to what? That is the reason of this t. This t is changing the value of x and changing the value of y. So, our dy dt is equal to what? Of course, we are going to differentiate this with respect to t. This is 2t negative cosine of t, derivative with respect to t, which will be 2 times 1. The differentiation of derivative of one variable is 1, then negative t derivative, then sine of t. We know that the derivative of cosine becomes sine, which is a negative, and this is equal to t plus sine of t. That is our dy dt. Now, what about our dx dt? Dx dt. Remember that we are finding dy dx. So this is equal to 3 sine of t derivative, and this is equal to 3. We know that sine derivative become cosine, so it is t derivative then cosine of t, which is equal to 3 cosine of t. This is our dx dt. So now according to this, our dy dx is equal to dy dt, this one, 2 plus sine of t dividing with dx dt, which is 3 cosine of t. So this is how we differentiate a parametric equation, and we can use this when we are finding like the differentiation of parametric equation, you can use this when you're finding like the gradient. You can go with the tangent line to the parameter. You can go with any other applications of differentiation, but considering the parametric equation. Let's take another example. So this is another example, and we need to show that our dy dx is equal to t 2 negative 1 divided by 2 then e power 3t. So this is the next. This is our next example. We are going to show that this dy dx is equal to that expression, considering that parametric equations of the curve. Considering that parametric equations of the curve, we have that our x is equal to this one and our y is equal to this one. Then we need to show that our dy x is equal to this. Now, as we have said, when we are going to find dy dx, we find the derivative of y with respect to the parameter t, with respect to y to parameter t. So our dy dt is equal to, we're going to differentiate this t squared, then e power negative t, negative 1, derivative. And this is equal to what? Of course, when we're going to differentiate this, we see that you have the product rule. You have this t squared, you have this e power negative t. So we differentiate t squared times e power negative t. We add e power negative t. Derivative then t squared. From the product rule of the differentiation. Then we subtract the derivative of 1, which is 0. This is the differentiation of this, and this is the differentiation of this. Now, this one is equal to 2t. We drop this 2, then we remain with t power 1 times e power negative t. Then plus e power negative t. We drop the power, as we have seen from the differentiation of exponential function, the previous videos, and then it is t, which is negative, derivative then e power negative t, then times t squared. So this is 2t e power negative t, negative, this is 1, which is negative because this t is negative, then e power negative t squared. So here it is allowed to put this t and e power negative t out of bracket as a factor. So we say that t e power negative t to negative t to negative t. Now This is our dy dt. We are going now, to find our dx dt. Because we are finding dy dx, we are going to find our dx dt. This will be equal to what? It's the derivative of this. Derivative of e power 2t. And as we have seen from the properties of exponential function, we drop this 2t, derivative then e power 2t. So this is 2 e power 2t. Now, we are going to take this dy dt, we divide with this dx dt. We take dy dx is equal to this one, t e power negative t, then bracket 2 negative t, which is this one, we divide with 2 e power 2t. So, from the properties of exponent, this e power negative t to be removed, we can multiply with e power positive t, we divide with e power positive t, like that. Then, when you multiply with e power positive t, this and this will simplify, and this one with this one will give e power 3t. So, this one is our dy dx is equal to t, then 2 negative t, dividing with 2 e power 3t. And now, you see that our differentiation or our derivative of parametric equation is correct. So, thank you very much. Hit like, hit subscribe, and don't forget to follow me. Don't forget to follow us. Thank you very much.